Good morning, students. I hope you all are doing good. It's me, Sarehan Yusuf, and it's your 7th lecture of physics. We started chapter number 3 and we discussed about the rest and motion. We also discussed about different types of the motion along with the scalar and vector quantities. We discussed about the distance, displacement, velocity, acceleration, and in today's class we are going to start the equation of the motion. So now we are going to derive the simple equation of the motion for the bodies traveling along a straight line with the uniform acceleration. Now let's derive the first equation of the motion. The first equation of the motion is v is equal to u plus at. It gives the velocity acquired by a body in time t. So consider a body having initial velocity u. Suppose it is subjected to a uniform acceleration a, so that after time t its final velocity become v, means the final velocity is v. Now from the definition of the acceleration we know that acceleration is equal to the change in the velocity divided by the time taken. And what is the change of the velocity? Change of the velocity is final velocity minus initial velocity. It means that a is equal to v minus u upon t. If we are going to shift t to the left hand side, so it will be multiplied by a, means at is equal to v minus u. So v is equal to u plus at. So this is your equation 1. Now here is the second equation of the motion. So the distance covered in time t by a moving body, that initial velocity of an object is u and the final velocity of the object is v. Acceleration is a, time is t. The distance covered in the given time is s. We know that the average velocity is equal to initial velocity plus the final velocity. As we all know that the initial velocity is u and the final velocity is v, so the average velocity will be u plus v upon 2. We know that the distance covered as in the given time is equal to average velocity multiplied by time, or as is equal to average velocity multiplied by time. After substituting the value of the average velocity from the equation 2, we get s is equal to u plus v upon 2 multiplied by t. Now here we are substituting the value of v from the first equation of the motion, that is v is equal to u plus at, and s is equal to u plus, and then in the bracket we are having u plus at upon 2 multiplied by t. As we open the bracket, so we get s is equal to u plus at upon 2 multiplied by t. So s is equal to 2u plus at upon 2 multiplied by t, means we are just going to multiply 2u plus at upon 2 by t, so we'll get s is equal to 2ut plus at square upon 2. Now if we are going to write them down separately, that is 2ut upon 2 plus at square upon 2. So from this equation we can see that if we are having 2 in the denominator and we are having 2 in the numerator, so both of the 2 will be cancelled, so we'll get s is equal to ut plus at square upon 2. So your final equation will be s is equal to ut plus half at square. So this is your second equation of motion. Now here come the third equation of the motion, that is v square minus u square is equal to 2as. As we know that the displacement formula is initial velocity plus final velocity divided by 2 multiplied by time, that is s is equal to u plus v upon 2 multiplied by t. And from the first equation we were having v is equal to u plus at. If I am going to shift u to the left hand side, so it will become v minus u is equal to at. And if I am going to shift a to the left hand side, so I'll get t is equal to v minus u upon a. Now here we are putting the value of the t in the displacement formula, that is s is equal to u plus v upon 2 multiplied by t, and again the value of the t we are going to substitute over here, that is s is equal to v plus u upon 2 multiplied by v minus u upon a. Now s is equal to v square minus u square. As you know, the formula for a square minus b square, that is a plus b into a minus b, and in the denominator we will be having 2a. So we are going to shift 2a to the left hand side, so it will be multiplied by s, that is 2as is equal to v square minus u square. So our final equation will be v square minus u square is equal to 2as. This is your third equation of motion. So that's all for today, and I hope you all understand the method for the derivation of the three equations of the motion. And for more practice, you can refer your book, page number 38, 39, 40. A detailed description is given over there. So that's all for today. All of you stay safe, stay home. Thank you so much.